Hello, and thanks for joining our webinar, Evolving Disaster Recovery into Resiliency. My name is Lauren Franco, and I'm a Field Marketing Manager here at OVHcloud. Before we kick things off, just a few housekeeping items. We are recording today's discussion, and we'll share out the recording later this week. We are excited to hear from you, so if you have questions, please submit those through the chat window. Let's take a look at today's presenters. I'm proud to introduce Mike Fincham, a Senior Systems Engineer at OVHcloud. With 19 years experience working in hosting and private cloud, Mike has passionately supported BC, DR, and IT resiliency customers in all verticals, including education, healthcare, and federal and state and local government. And joining us from Zerto, we have John Cousins. John is a cloud architect at Zerto and has a Bachelor's of Science in Computer Systems Engineering from the University of Massachusetts Amherst. He's a 20-year IT veteran specializing in software-defined data centers with a background in corporate IT for large organizations like Northeastern University and Harvard Medical School, as well as in IT professional services and IT technical pre-sales. Hi, John. Thanks for being part of today's webinar.
Thanks for having me.
So before I turn it over to the experts, let me take a minute and set the stage. Too often, IT executives view disaster recovery as just an insurance policy for their most important workloads, while leaving others unprotected. So how do organizations protect all of their workloads, fight back against cyber threats, and avoid the high costs that are often associated with a ransomware attack? Well, they evolve their disaster recovery strategy into a resiliency approach. And that is why we are so excited to be partnered with Zerto. Today, we'll share with you the power of application tiering, some design considerations, and approaches for evolving from disaster recovery to IT resiliency. So let's jump into it. And now I'll hand the reins over to Mike.
Thank you so much, Lauren. And thank you to everybody for joining today. So I'd like to begin today just by discussing who OVH is. What I have for you today is OVH by the numbers. So if we just take a look at who we are globally, or who OVH is globally, OVH has a total of 1.4 million customers worldwide, scattered across 138 countries. Those customers are running today on over 300,000 physical servers, and on those servers we have over 200,000 private cloud virtual machines running and over 600,000 public cloud instances created in just a month. Now, all of those workloads reside in one or more of OVH's 28 data centers globally that are located in 8 different countries. Our data centers are connected by a 15 terabit per second network that we own and manage ourselves. And within that network, we actually have a new number here, which is 5 terabits per second of anti-DDoS capacity, which we offer to all of our customers as part of our baseline pricing. Now, in terms of employees, we are over 2,500 employees globally. And I should also mention our network, in terms of customer access, we have 33 points of presence around the globe. So what does OVHcloud offer? So we have 3 tiers of business that we're going to talk about today. The first one is hosted private cloud, which is based on VMware's SDDC software suite. Within this offering, all of the servers are dedicated, and they are built using industry-leading components, including Intel CPUs. We also have a public cloud that's based on OpenStack that includes compute, storage, platform as a service, object storage, and then we also have dedicated bare metal servers. Now, the interesting thing is that we've got these services in our data centers around the globe, but we can connect them together across the network that I mentioned that we own and operate. So we have a 15 terabit per second fiber optic network that terminates in all the data centers, and we give our customers access to this data center for intra-data center traffic. Now, that traffic could be replication traffic in the case of disaster recovery, which we're talking about today, or it could just simply be workload traffic. We have the ability with a piece of technology that we have that's proprietary to OVHcloud, it's called VRAC, to make workloads that are in different data centers or within the same data center but on different products appear to each other in the same layer 2 space. Now, we support all of these products together with 24/7 white glove customer support and professional services. Today, we're going to be focusing on disaster recovery. And with disaster recovery, we all understand that it can be devastating to your business. If you're here today, you've got some level of inquiry into DR, and you probably understand the threat that it poses to your organization. Most companies measure that threat in terms of dollars. So if we look at the broadest number, and this is a number that we get from our analyst community, 98% of organizations lose over $100,000 an hour in a downtime event. So that's almost everybody at 98%. 81% of organizations lose over $300,000 per hour in a downtime event. Going up the stack to larger organizations, roughly a third of organizations who experience downtime lose $1 to $5 million an hour. And possibly one of the scariest numbers on the slide here is that 93% of businesses who experience a significant data loss declare bankruptcy within 1 year. Now, as I said, since you're here today, you probably already have a strong understanding of this. The question is, what are we doing to address those concerns and that potential risk? DR today is a 20-year plus evolved concept, right? It's a very mature concept. Well, what we're seeing as we look across the community is that there's an evolution taking place from disaster recovery to what's being named IT resiliency. So the question really is, what's the difference between the two? So we have a slide here that addresses it at a very high level. So if you think about the beginning of disaster recovery and just array-based replication, that started as an event-based driven concept. DR evolved on the idea that what do we do if we go down? So it's inherently focused on events and downtime. In the new world of IT resiliency, we certainly have events in mind, but we're focused on being continuously available even in the event of downtime. In the past, we might have thought of that as high availability, and that's still a concept we embrace, but continuous availability is a little bit different. We're looking for ways to do it that are not as cost prohibitive as true HA. Another way to think about it is that disaster recovery by its very nature is always reactive, or was always reactive. It's a response to events, and those events usually take the shape of natural events or outages associated with facilities, hardware, or networks. In the world of IT resiliency, our design is proactive. So we're resilient by design. We've got more than one copy of our data accessible in different locations at all times, and we have methods to make sure that information is available to our end users as quickly as possible. Probably the best way to understand the shift that's taking place with IT resiliency is just in how we're measuring the downtime that we just talked about and the financial impact that's associated with it. For the past couple of decades, we've been talking about downtime being measured in hours and days. With the new technologies that are available to our community, we now measure downtime in minutes and hours. And it's a change in mindset. So with that as a basis for understanding, what I want to do is shift to a discussion around how you tier your applications in an effort to be continuously available. As I talk to you about this, I'm going to talk to you as if I was talking to one of my customers. When we engage with our customers, we begin to try and understand, what are you doing today? And then we share these type of thoughts that I'm going to share with you as part of the overall engagement. But the important thing to understand right off the bat is most customers today are not tiering effectively. By and large, when I go in to see a customer and I ask them, are you tiering? The answer is typically, well, we usually have one tier. And Gartner backs that up. 61% of customers, as surveyed by Gartner, only have one protected tier in their DR site. If you take a look at the graphic on the right, when I'm talking about tiering, I'm really talking about 3 tiers. There's mission critical, business critical, and non-critical. And as you can see, they're roughly split in thirds. Why would I want to do something like that as opposed to having one blob of protected workloads? Well, it gives me flexibility. Breaking my workloads into these tiers of mission critical, business critical, and non-critical enables me to utilize multiple replication tools that are purpose-built for each one of these tiers. And it also allows me to then associate costs at each one of these layers. So when I start thinking about mission critical, business critical, and non-critical as having their own independent tool and methodology for coming up and even associated recovery times, there's also an associated cost that I can balance across these three. So if we take that back to the initial idea that most customers are not tiering effectively, if you're putting everything into one recovery blob, you're only able to use one tool and you only have the option to apply one costing measure towards it. So tiering gives you the option of being flexible and saving money while at the same time applying best practices across all of your tiers. So what I want to do now is begin to drill a little bit deeper into each one of these tiers. I take that back. We should start here. In terms of grouping the applications into tiers, let's explore it just a little bit more, beginning from the bottom up. With non-critical workloads, we define these as workloads where the data loss can be tolerated up to 24 hours. And typically, we are restoring from an offsite backup, and this is fully suitable. There's a very large portion of the market out there today that is still working across the board with this as their number one solution. They're backing up to one or more devices locally, and maybe that device is snapping a copy to another office location, and that's it. Above that is business critical. In the business critical zone, this is where we want to focus on minimal data loss, and we want to get our RTO, our recovery time objective, and our RPO, our recovery point objective, as tight as possible. Now, I refer to this as the Zerto zone. This is, since we are here today with our partner Zerto, this is where we as OVHcloud talk to our customers about applying Zerto and the strength of their software suite to protect their most valuable workloads. Mission critical workloads are a different animal. Here we're talking about zero data loss. This is a small percentage by definition of the overall workloads that we want to protect. That's why we have it at the top of the pyramid. And these are more challenging to protect than the lower two layers. And what you notice on the right-hand side is that as we go up the pyramid, our total cost of ownership goes up. Non-critical has the lowest cost associated with it, and as such, this is what you find a lot of customers gravitating towards because they're struggling to justify the monies that they need to allocate to their BCDR planning. And at the top we have mission critical. Mission critical and zero data loss, that implies high availability, which has been around for a very long time, and we understand that to be an expensive methodology. If we look a little bit deeper into mission critical, these are applications whose use and availability directly impacts revenue, customer service, and the reputation of the organization. Here we really have no tolerance for downtime. So as I mentioned, we typically architect for high availability and continuous backup, and we do that using clustering or native replication technologies. So the easiest example to think about here would be database replication. So SQL replication being probably the most predominant type out there, but other similar software, they have the same concept built in. Stretch clustering is an idea you might be able to feel familiar with. Another thing that we see as extremely important in the mission critical tier are pilot light applications. Now what I mean by pilot light applications, these are things that we would call identity services. So Active Directory, domain name services, virtual private networking, these are all here in the mission critical zone because when I bring up the virtual machines that I'm protecting in my business critical and my non-critical zones, they need to know where they are, who they are, and where they go to be accessed. So that's where Active Directory comes in and domain name services come in. VPN is for my end users to be able to access the environment that is recovery. So these are always part of a standard disaster recovery design when we engage with our customers. Now, if we talk about the clustered applications, the most common applications that we see when we engage with customers are high transaction databases, again, SQL, Oracle, things like that, Exchange servers, and e-commerce applications that have got clustering capabilities. Now, if we talk about some other things that we'll find in our mission critical layer, one of the things you frequently find that's difficult to solve for are mission critical applications that are not virtualized. So probably the most easy example to understand would be maybe a database that you have sitting in your data center today that is not virtualized either by rule. We don't virtualize databases, or we don't have the skill or the resources available to virtualize that database. So how am I going to protect that? Some other examples are just legacy applications that are homegrown. These are something that's coming out of your own organization that they're sitting on a physical server today, and it's difficult to replicate these workloads. Another thing that we find very frequently in mission critical layer is applications where the licensing does not align with cloud consumption models, meaning maybe it's a database that's got a licensing rule that says you have to license this for every possible CPU core that the software can see. And so putting that on a dedicated host allows you to constrain the number of CPUs that workload can see, and thereby it contains your cost. So up to date, where would we solve for that? Usually these workloads wind up in a co-location cabinet. So if you think about the way a lot of customers do it today, when I engage with them, they'll tell me these things are sitting in a colo next to their recovery site, and there's a cross-connect running from their cabinet into whatever their recovery site looks like. What that means is you're dealing with multiple vendors, you're dealing with a cross-connect, potentially multiple networks in the data center, and it inherently raises the complexity of the solution for the customer. What OVH can do at this layer, which is unique to us, we have two products that you can see on the right-hand side. We have our hosted private cloud, which is running on ESX, NSX, and we also have dedicated bare metal servers. We can connect those two product lines via the VRAC solution, which I mentioned. That's a layer 2 adjacency solution that says these two disparate products can essentially live in the same layer 2 space. And what that means I can do is, for something that's not virtualized and I don't want to virtualize it going into a disaster recovery scenario or a resiliency scenario, I can keep them not virtualized, and I can place those workloads on OVH dedicated servers, and I can connect them together. This is a powerful combination. Just speaking anecdotally, when I engage with my customers and we do a site survey, usually the virtualization in the data center is somewhere around 90% or higher. But what that leaves us is, somewhere between 1 and 10% of those workloads are not virtualized. So having a dedicated server platform, bare metal, that we can bring to bear into the overall DR solution really increases your options to protect everything that's in your data center. Now let's talk about the Zerto zone, or the business critical layer. This is the lion's share of the workloads that we protect for our customers. Here, these applications, these are important to the business, and they can experience some downtime without affecting revenue, but it needs to be as little as possible. So replication solutions in this tier inherently should have a high level of automation and orchestration. They should be very simple to deploy and configure, and most importantly, when it's time to recover, I should be able to do as little as possible, hopefully a one-button push, and be able to begin my automated failover. So in terms of the SLAs that OVH supports, generally speaking, at the highest level, we target about a two-hour RTO and a recovery point objective of 5 minutes or less. Here, we apply Zerto. This is our premium solution. This gives us everything I described. Zerto has automation and orchestration. It has a near seamless failover. One-button failover is what they like to talk about. And it even gives you the ability within their software to group your workloads into virtual protection groups, so you can establish which workloads have to come up first. And that loosely aligns with the idea that I need that this tier 1, or my mission critical workloads, those have to come up first, even in my business critical zone. Now let's take a look at non-critical. These are applications that can experience downtime without drastically affecting the business. The typical RTO target, or recovery time objective, here is 4 to 24 hours, and we can tolerate data loss up to a full day, or 24 hours. Here, this is where we save money, right? If we're spending most of our money to protect our most valuable assets in mission critical and business critical, We want to save money in the non-critical layer. And we want to look for tools that have the lowest cost. What that means is they may not be feature rich. They may not offer orchestration or automation. They may have RTO and RPO targets associated with them that fall into the zones I described. But it allows us to save money. Now, what would these look like? What would I suggest that you use? So since we are tightly partnered with VMware, I would describe vSphere replication as fitting into this zone. It's a zero-cost solution. The RPOs are 5 minutes and above, depending on which version of ESX you're on. There is really no orchestration and automation associated with that software itself unless you purchase Site Recovery Manager with it, and then you're getting into higher costs. One of the things that our customers do in this zone, I should take a step back. This is also a place for you to bring your own backup. So if you are using a traditional backup solution today, Commvault as an example, or Veeam, or whatever you've got, this is a place where you could deploy this. You could target resources that we have in the cloud, and those could be a hosted private cloud resource. It could be a storage host that we have sitting in our cloud that's networked to your hosted private cloud. You could replicate to that yourself, and you could then restore those workloads into your target recovery hosted private cloud. So this is where we save money. We fall into these constraints, and it's a great way to segment our workloads and make sure that we're treating all of them individually and giving them what they need. Now, one of the things that's unique about OVH is that we are not multi-tenant. Our guaranteed resources translates into these are dedicated servers for you. In our hosted private cloud, you're single tenant on your own dedicated servers. With the dedicated servers that are bare metal, that have no operating system on them, these are all yours too. So they are inherently secure. Now, if we look at our statistics from our analyst community, Forrester highlighted the fact that 20% of customers today that choose to outsource use a shared or fixed infrastructure site as their target. What does that mean? Well, there's some inherent risk there. That means if there's a large geographical outage on the East Coast, potentially I'm not going to have my resources available because everybody is flooding my DR provider. It also means that potentially a bad actor that is existing within my multi-tenant solution for DR, might cause some havoc within that platform. So when possible, I make the recommendation as a solution architect to choose a single tenant solution. So what's the benefit there? If there's a cost benefit analysis being done here, what am I giving you in exchange for that? Well, I'm giving you a service level agreement for recovery time objective, recovery point objective, as well as the other components of the solution. So when you start thinking about storage SLAs, network availability SLAs, this all becomes a much more robust solution where your vendor is putting some stake in the game to say, we're going to protect you and these are guaranteed to be available. When we talk about security and guaranteed resources, the most obvious example is if it's single tenant, I'm controlling my access, I control the firewall rules, I control everybody's permissions within the environment. That's inherently more secure. But what it also speaks to is my ability to think out of the box. So another statistic here from our analysts is that fewer than 50% of organizations are performing malware checks on their backed up data. So let's say you're backing up your data today into your single-tiered blob. Over half of or roughly half of our customers out there, they're not performing any type of virus or malware check to make sure that when they recover that their workloads are not inherently compromised. So we're going to touch on this with Zerto in just a second. This is where Zerto's journaling capabilities enable you to avoid that situation. But one thing I want to point out is that with our hosted private cloud, we offer you NSX as part of the package. NSX is VMware's software-defined networking suite, and probably the top level value that they talk about when they engage with customers on NSX is the ability to microsegment. And all microsegmentation means is I can set up security policies that are enforced within the hypervisor. of my hosted private cloud, and they are enforced actually at the VNIC layer. So when a virtual machine in a recovery site wakes up and it tries to access other parts of the hosted private cloud, it is going through security checks at the virtual NIC. What that means is I can segment my traffic within my solution. I don't have to do a bunch of networking tiering in my DR site. I can simply say that web servers only ever talk to application servers. They never talk to database servers. Sort of standard stuff that we do today with a bunch of firewalls. We can do that with software-defined networking from VMware. So it's a very secure disaster recovery solution. Now, just a few final suggestions when tiering applications before I hand this over to John from Zerto. And this is something I tell all of my customers. The first thing is when we get involved with this, I ask them, are you aligned with everybody in the business? Does everybody know that we're going through this exercise together? And when we go through and analyze these workloads, are you going to share with them where you're categorizing their workloads? And then the reason that's important is that if you do this alone as an IT silo, and then you enforce these things and you find yourself in a recovery event, there might be a workload that you've classified as non-critical that it turns out is actually mission critical, and that can actually create a negative impression of IT. So make sure everybody is involved in your BCDR planning. Then the next step, the very first thing we do is collect the details. And what that means in most cases is sitting down with the vCenter administrator in your business and getting a vCenter export. Sometimes we can work with a tool like vRealize Automation or vRealize Operation to pull out something like that. And then we go through workload by workload and we start assigning tiers. As a rule, I tell my customers that they should use mission critical sparingly. Generally speaking, no more than 25% of your applications should be mission critical. The primary reason for that is it's going to drive up your cost and it's going to drive up your networking consumption or your network consumption. Anecdotally speaking, I rarely see 25% of workloads in mission critical. Generally speaking, the workloads that I mentioned as being pilot light, Active Directory, DNS, VPN, and maybe some databases, that's what typically lives there. And then take your time to tier carefully. Go through a tiering exercise, take it to the stakeholders, talk to them, make sure they understand what you're doing, and then go back and do it again. Make sure that your tiers make sense, because if you don't, then you're going to drive up your cost and potentially drive up your complexity. So at this point, I'm going to hand over the presentation for a few slides here to John Cousins from Zerto, and we're going to talk about how Zerto journaling protects against cyber ransomware.
Thanks, Mike.
Sure.
So ransomware is basically the new threat that all of us are facing, probably the biggest one that all of our companies are facing. Here are some overall stats for kind of what's affecting us. Some side stats that I looked up on my own as well. The first reported incident of ransomware actually goes all the way back to 1989, which I didn't realize. I think it was at MIT. There was a software developer that developed a virus that locked computers and required a ransom to unlock them. He was caught and found unfit to go to trial and had to give all the money to AIDS research, which is strange. I guess it was the 80s, so that's where all the money went from that. So it goes quite far back where ransomware comes from. It's not a recent thing. What we're all aware of is what happened in May 2013, which was one of the biggest heaviest attacks with CryptoLocker, and was using newly minted Bitcoin as payment. So a new way to hide all your payment. And then hackers are also using the Tor network to kind of hide all of the traffic that they're doing. So they're very hard to catch, very hard to track these down and find the people that are doing the attacks. From October of 2013 to December of 2013, there was 27 million collected by hackers, just to give you an idea of how much money was collected just that year. Last year, in 2016, the FBI put payments in the neighborhood of $1 billion for all companies paying out ransomware payments. So just to show you the effect that it's affecting on all of our businesses. Let me show you one thing that hits near and dear to both me and Mike. We're both in the city of Atlanta. You all are probably aware of an incident that we just had suffering a ransomware attack that kind of crippled our city for a couple of weeks. So back in March, the city experienced a SamSam ransomware attack. SamSam can be pretty bad. It has tools built in that allow it to cover its tracks, including deleting files. It can even delete like VM snapshot-based backups that you have maybe sitting out in a CIF share. So different products that use VM snapshots and then dump their backups to like a data domain or an exagrid or some type of CIF share. SamSam even has tools that it can go in and delete those backups. So we've seen customers that that's happened even before. So even having the backups might not be your solution here, because even those are just sitting on vulnerable CIF shares, right? The city of Atlanta, the hackers actually demanded $51,000 in Bitcoin. Interestingly, the city didn't pay. What we ended up doing was we had a brand new mayor. She actually published the URL for the site to pay the ransom. And the hackers got scared and ended up removing the site completely. So the city had no way to even pay the ransom. They had to basically figure their way out of it at that point. They ended up spending almost $3 million, which seems like a lot, but it's pretty standard for this type of attack. Companies are spending $3, $4, $5 million to recover from this. So Atlanta didn't do too bad to recover. $650,000 of that went to SecureWorks just to assess the damage. 2 more contracts were paid $1 million each to private tech firms to bring up all of the city's municipal court systems. It was affecting ticketing, and all of the police stations were having all of their systems affected as well. $600K consulting to Ernst & Young just to get everything back and working. And then the funny stat I thought here was $50,000, which was the original demand from the hackers just to pay PR firms for crisis management, crisis communications. So pretty typical of what a city would spend. One thing with Atlanta, we had failed a lot of security audits in the past, but like any municipality, there's a lot of bureaucracy. It took a long time to get anything holes plugged. The good thing that came out of this is the $2.7 million, a lot of that was spent plugging the holes that caused the problem in the first place. So if we would have just paid the Bitcoin ransom, those problems still would have existed, and we probably would have got hacked a couple months later. So it was a painful way to forcibly get the city to fix its broken IT systems. So here's what a typical DR data protection solution would look like. Mike mentioned that non-critical systems typically have a recovery time objective of 4 to 24 hours with a 24-hour RPO typically. You're typically taking a backup once a day, maybe 2 in the morning, hoping it finishes by 7 when everybody comes into work, and that's your last known good point to recover from if you have any kind of disaster. Unfortunately, in the real world, most organizations are still protecting business critical systems with non-critical data protection solutions. So an infection happens at some point of the day, whether it be a virus, malware, ransomware, hardware failures, or simply human error. Somebody deletes a file by accident. We all use the same strategies, essentially. We may have different technologies to satisfy all of those different events, but the principles are still the same. A disaster happens, we roll back to your last known good backup, which is usually every 24 hours. Now, as a side note, Storage Magazine reported that 34% of companies don't test their backups. Mike mentioned that as well just a minute ago. And then of those 34% that do actually test the backups, 77% found that the tape backups failed to restore. And according to Microsoft, 42% of attempted tape backups failed last year. That's not even looking at the backups to see if they're valid, if they have ransomware or any kind of viruses within the backups. That's just not even being able to do a restore, right? So, tape is, we all know tape is painful. It's slowly becoming a legacy tool, but like a lot of times, most organizations aren't testing that backup data, and Atlanta probably was one of those as well. Another way to improve the 24-hour RPO is maybe using snapshots, right? So you can use VMware-based snapshots, which we know aren't really supposed to be used for backups. They're really more for configuration changes, like you did a patch Tuesday for Microsoft, you took snapshots in case one of the patches was bad, and you roll and you delete the snapshot the next day. They're not meant to take a 1-month snapshot of your Exchange server. And if anybody's ever done that, you'll see how painful it is to try to push that snapshot back into your original virtual machine. You could get SAN-based snapshots. Will give you a little bit better RPOs. Sometimes you can get down to 15-minute RPOs with SAN snapshots, but they're very expensive. It requires extra storage to store those snapshots. And it also requires like-for-like hardware if you're going to replicate those snapshots to another site. So if you're going to send those snapshots over to the DRS site, you have to have the same exact vendor of storage array on the other side to receive the snapshots. Sorry, go ahead, Mike. So where Zerto does things a little bit differently is we take the IT resiliency approach rather than the disaster recovery approach. We are always on continuous protection for your VMs in the form of incremental block level replication with zero performance impact to your production environment. So rather than point-in-time snapshots, Zerto is keeping a remote journal of all incoming changes to your application stack at the hypervisor level. Think of us as a DVR for your VMs. So the journal would be the hard drive inside of your DVR, allowing you to rewind your VM to up to 30 days prior to any point in time. As a result, as Zerto replicates data every few seconds, we check for consistent points in the data for a VM or a group of VMs, and we write what's called a checkpoint into the journal. These checkpoints are the points in time you can actually rewind back to in the journal. So imagine you're watching Netflix movie and you want to rewind frame by frame. You can do the same thing with a virtual machine. I can rewind 7 seconds, 14 seconds, 21 seconds back. Right, so like Mike mentioned, we're bringing your recovery time objectives and recovery point objectives from days and hours down to minutes and seconds now. So imagine if Atlanta was protected with Zerto and they could recover back to 7 seconds before the ransomware affected them. They could have saved millions of dollars, right? So if we're hit by a virus, you simply check the timestamp and say it happened at 6 a.m. You could find a Zerto checkpoint at 5:59 and 53 seconds and roll back to that, and with only 7 seconds of data loss, right? This is pretty critical if you're any kind of credit card transactions happening. That could be 7 seconds is small, right? But if you're having to fail back 24 hours or 4 hours or 15 minutes and you lose 15 minutes of credit card transactions, that could be millions of dollars for your company, right? So here's what's involved with configuring the journal. Basically, there's a few configuration steps. You set SLAs for each of your customers, so a max time to keep checkpoints for, and that's just determined based on the offerings that your OVH is selling you and what you want to afford, whether you want to keep 1 day of checkpoints or 4 days or 30 days. That'll obviously increase the amount of storage that you're using and the cost of the solution, but that's an SLA that you set with your provider. You set a size for the journal, so you can have it set to an unlimited size if you want it to just be able to take unlimited checkpoints. Or you can give it a hard limit. Say you want to hard set your journal to 20 gigs. What will happen is, say you had 30-day history, but your journal fills up in 1 day because you hard set it to 20 gigs. It's just going to keep only having 1 day because that's the max checkpoints it can keep for the hard limit you set for the journal. And you also choose a data store where you put it, so you can choose dedicated data stores just for journals so that they're not affecting virtual machine traffic, or they're not, you don't have to worry about them filling up space of where your virtual machines are sitting. That's a choice that we allow you to choose the data store where to put it. And then all data is also compressed, so saving you WAN bandwidth before we send it to the other side, and it's also compressed within the journal to save you storage space on the other side. The compression is typically pretty high. It's usually about 80%, which you can see in our UI. So saving you a ton of WAN bandwidth as well. So a little bit of WAN optimization before we're sending the data over there as well. And then basically the journal is just essentially a FIFO queue, a first in, first out queue. It's just a VMDK on the other side. It's pulling in 16 meg chunk block changes at a block level from the production site. When that FIFO queue fills up, it basically pops the oldest data out the other side and into a vReplica disk, which is just a VMDK if you're VMware, or a VHD if you're Hyper-V. That's your VM that you'd fail over to. That's your actual VMDK. So it's just a set of 2 VMDKs that merge their data together every once in a while. So failing over is really simple. It's just a few simple mouse clicks, right? You literally click the failover button. Once you click that, a pop-up will come out and allow you to select your VPGs or virtual protection groups, which Mike mentioned earlier. Mike, you can advance the slide, please. And then once you select your applications, sorry, go back. You missed one there. But once you select your applications, it's going to ask you to select a checkpoint. You'll see a list of all your checkpoints, which are usually in, 10-second intervals, maybe less even. And you basically just choose a checkpoint before any of your disaster event happen, and you click Start Failover. The beauty of all of this is that it's not just a replication tool, it also has built-in orchestration and automation as well. So you can orchestrate changing the IP addresses when you fail over to a new data center with a new IP scheme, changing the DNS servers to point to the new critical DNS servers that are already running in that environment. You can run pre and post recovery scripts right from within the Zerto UI. So say you wanted to run some PowerShell script that's going to do something to your application after you've failed over. You can write that into the scripted failover. And you can also set boot orders. So you can set, your DB server to come online first, then your application server, then your web server, so that the app comes up in the right orders. So all of this is orchestrated and automated. That's the beauty of the product. It's not just a replication product like vSphere Replication. It's giving you the built-in automation to just push a button and fail over as well. We can also do individual file level restores as well. So we can recover an entire site. We can recover an entire application. We can recover a single VM or groups of VMs, or we can recover individual files as well. And that's pretty simple. You do a restore process. You select the VM that you want to recover a file from. You select the checkpoint as well. You select the disk. So if there's multiple disks on that VM, say it has a C, D, and E drive, but you only want the D drive, you select the D drive. And then basically it gives you an Explorer-like window to browse for the files or folders you want to restore. And then we give you an option to restore those to any location. So currently in this version of Zerto that's not indexed, coming in Zerto 7 in the beginning of next year, that will be fully indexed. So you'll be able to do Google-like searches for any of the files within your VMs. And we'll also be able to extend the journal out from, now you can go up to 30 days, it'll be extended out to 7 years coming in the next release in Zerto 7. So that's the future of the product. But you can see the ease of just being able to basically push a button, fail back to a few seconds as opposed to 24 hours ago is pretty critical for us. That's why we're in the business critical zone, right? Like I said, if we were the city of Atlanta and they were protected with Zerto, they could have avoided paying that $2.7 million. It literally would have been an IT guy going in, clicking start failover, checking a box a few minutes earlier, failing everything over and bringing the systems back online. Now we might have got hacked again because the systems were still all insecure. But that would have at least bought the city some time to be able to fail back, get back into production, and not have to have that huge outage and expose themselves to the world like that.
Thanks so much, John.
Thanks, Mike.
We're just going to quickly go through a few tools. Well, I want to talk about how we can configure some of the products that we offer at OVH into disaster recovery solutions. And we've touched on this earlier, but I just want to remind you as we're wrapping up. So again, just a quick view of the products that we've discussed today. So primarily we're talking about hosted private cloud, which features VMware software-defined data center that is built on dedicated hosts. As a customer, you receive direct control of that environment. And then we also talked about dedicated bare metal servers. These are non-image servers, and we can connect these together in the data center or across intra-OVH data centers across our network and make them in the same layer 2 space with our vRAC technology. So if we talk about the specifics of what do you get in hosted private cloud from OVHcloud, we start with the SDDC stack. So as a customer interface, your primary operational day-to-day interface is going to be vCenter. And the great part about that is that hopefully that's going to feel just like your data center today. There's not going to be a new skill set to be acquired, not a new certification. This is just like your day-to-day experience. Now, what we're offering as part of our offer that is new to a lot of our customers is VMware Software-Defined Networking Suite, which is NSX. A lot of customers have not made the investment into NSX yet, so it's a great feature to offer as part of our DR. We offer also as part of our hosted private cloud offering. Those together give you a tremendous amount of power and configurability in terms of access control, role-based administration, security policies. And I should mention, if you're not familiar with NSX, as you're looking at this, you might be thinking, well, where's my firewalls? Where's my security? That's all done in NSX as part of software-based firewalling. So NSX comes with what's known as edge gateways. Those edge gateways do all of your ingress and egress processing. So they have stateful firewalls. Layer 2 VPNs, IPsec VPNs, SSL termination, everything that you could normally do as part of your front-end stacking your data center, that's virtualized as part of VMware. Now, from a storage perspective, and I should mention, as part of the SDD stack, you always start with 2 hosts. And this is an interesting thing when it comes to DR. So if you think about production hosted private cloud, best practice is to give you 2 hosts because you want one of those hosts to be available for high availability, or HA, within ESX. Now, a lot of customers look at that as an opportunity to take savings within DR. You don't have to keep that high availability configuration in your disaster recovery site. So what that means is you really double the available resources that you have in terms of RAM and compute that you can then use to recover. From a storage perspective, we offer you 2 data stores always to start. Those are ZFS based. We can scale up as high as 2 petabytes per customer. Generally speaking, in terms of limits across what you're seeing here at the top level, we adhere to published VMware maximum. So if you're wondering how big of a VM can I run, how much storage can I run, we would always refer you back to VMware's published limits. Now, in terms of add-ons, which we've been focusing a lot on today, primarily we're looking at Zerto. That's our number 1. We have vRealize Operations also. We also have from VMware Hybrid Cloud Extension. And what Hybrid Cloud Extension service is, it's a service, a hybridity service that allows you to connect your data center to your target data center and do either low downtime migrations or live vMotions of workloads from your data center into your DR target data center or your alternate production site. And then we also have public IPs that we make available to our customers to place on those edge gateways that we talked about at the beginning. Now, in terms of what's available for the dedicated bare metal server line, we have 5 classes of servers. Predominantly, our customers focus on the infrastructure and high availability servers. So infrastructure servers here, these are single, dual, and soon quad processor hosts. This can be used for almost everything. The only thing that's different about these is that they are a single power supply to start. High availability is going to be the same idea. It's always going to be dual CPU. These are going to be higher grade CPUs, higher cores, higher threads, higher clock speeds, and then it comes with redundant networking and power. You can see some associated use cases on the side. Now, the other one that's extremely useful when we think about the non-critical workloads are our storage hosts. These are high capacity storage bare metal hosts, and their primary use case is to be a target for a backup suite that you're running on-prem. So if you think about the do-it-yourself backup that I talked about, Commvault, Veeam, or anybody else, they'll allow you to choose secondary and tertiary targets for your local production backup. So what that means is you could take a copy of your backups locally of your non-critical workloads, and then you could put a copy of those in the cloud as well. And I would tell you to target the storage host there. And then we also have GPU hosts available. This comes in a little bit more of a niche market for us when our customers tell us that as part of their overall DR strategy, they need to protect some desktops. That's where these bare metal hosts become very useful. That's their primary use. And then lastly, we have game servers here. Those don't really apply to the conversation that we're having today. But overall, when you combine these 5 classes of servers with the hosted private cloud that we just talked about, you have a very flexible platform. Now, this is just a quick look. We've got about 10 minutes left here for questions, so I just want to highlight a couple things on this diagram. This is a typical topology, a logical topology of what we might deploy for a customer. So you as the customer on the left-hand side, you've got a data center and you've got ingress and egress at some point here in the top right-hand corner. So typically you would be able to connect to us over the internet. What would you use? What would you pass over the internet? Well, typically you would do replication over VPN. Most times what you're looking at there is vSphere replication comes to mind. There are other capabilities you could pass across the internet, including Zerto. We also have the capacity to do live vMotion migrations over the internet. Now that utilizes VMware's Hybrid Cloud Extension service that we didn't touch on today. That's more of a premier service. We've been focusing on Zerto. And then we also support private connectivity. So if you look at the black line, this is a dedicated circuit. So in customer terms, this would be maybe layer 2 Ethernet that you own, or layer 3 MPLS or AVPN. What you would do if you have that today, you would find a way to terminate that in an OVH point of presence. And from there, your traffic could ride across our VRAC Connect service, which is part of the VRAC that is built into our data center. So essentially you hand off there and you're on the OVH network, and then your replication traffic or your end user traffic comes across that high throughput, secure, predictable bandwidth, and it lands on the right-hand side here in an OVH data center. And what I would call out here on the OVH data center side, what we see many times in our customer environments is they will elect to create a DMZ where they would place some of those pilot light workloads that we talked about earlier. They'd have another LAN segment dedicated to the clustered workloads we talked about, and then replications. And those replications would typically be Zerto, but they could also be one of the other technologies we talked about. And lastly, I would point you towards the dedicated server down here at the bottom. So we've got hosted private cloud at the top, dedicated servers at the bottom, again, connected across VRAC. And so if you'd like, we can get you a copy of this topology if this is interesting to you. But that wraps up our discussion for today. I want to thank you very much for attending, and we're going to take some questions at this point. Lauren?
Yeah, wonderful. Thank you so much. Appreciate the discussion, Mike and John. I do have a couple of questions here. So there is also still time to submit more questions as well. So let's take this first one. John, I'll let you answer. It says, so in the case of Atlanta, what is the lesson learned?
The lesson learned is they should have used Zerto. The lesson learned is probably that they didn't do proper tiering like Mike spoke of. They were treating every single one of their applications as non-business critical applications and just backing up with typical backup tools, right? They weren't treating anything that as if it needed to be brought online immediately. This isn't, I'd say, something unique to Atlanta. This is probably, 90% of organizations out there are kind of like this. They don't really take the approach of IT resiliency until they have a disaster and realize how hard it is and how slow it is to recover. So I think the lesson learned is that they're going to have to start not only securing their systems better, but also tiering their applications and backing up certain things or replicating things in a different way than they were currently doing.
Right. Okay. Here's another one. Mike, let's have you answer this one. So it says, how do I get started? We've engaged stakeholders, but how do we get everyone on the same page to identify what's mission critical and what's non-critical?
Right. So thanks, Lauren. As I mentioned, right, it usually starts with getting a export of all of the workloads in your data center. And most times that looks like a vCenter export, but it could be VMstar, it could be a vRealize automation output. There's many ways that we can take a look at what you've got, but what we want to do is sit down, starting with IT, and group them. IT typically knows what we can weed out. Then once we have a clean list, we could begin to even take a guess and start doing some color coding. And let's do stoplights, right? Mission critical is red, business critical is yellow, green could be the non-critical stuff. And then once we've got a list, we break it out into maybe tabs and we take it around to our groups and say, do you agree what we're doing here? Have we overlooked anything? Are any of these systems that we've outlined here, if they are not available, what's the impact to you? And that can take a week or two to get all the way around the business based upon people's schedules. But once you've done that at least once, you can have a lot more comfort in knowing that the plan that you're putting together is going to meet everyone's needs.
Yeah, and I thought your point earlier, too, about the financial implications. Once you start to show people the dollar signs, or at least dollars saved, goes a long way.
Absolutely.
Okay, here's another one. It asks, is there any distance limitation between customer premises and OVH data centers for Zerto replication?
No, not at all. Honestly, our minimum requirement is a 5 meg bandwidth between sites. That's pretty much it. What will be affected by slower pipes or super busy servers is your RPO. So if you have a high pipe to replicate data, you can get the RPOs down to 5 seconds, 7 seconds. But if you're only you're trying to replicate a huge amount of data over a 10 meg pipe, those RPOs might bump up to 5 minutes, 10 minutes. It just depends on how much data you can push over the pipe that you have. Like I said, we have no real limitation other than 5 megs is kind of the lowest that we'll say. And I honestly, I've had VMs replicating at home over nested ESXi environments that have less bandwidth than that. So it's really just, it just depends on what kind of an SLA you want to have. So if you want to have that 7-second SLA, you just have to have a faster pipe between the sites. But with OVH, that's not going to be a problem because of the huge dedicated pipes they have between their different data centers anyway.
Right, and it's worth mentioning too that in the hosted private cloud, each of our customers receives a network handoff that has with it 1.5 gigabits per second of capacity available to you. So the limitation will not really be from a bandwidth perspective unless you're an extremely large customer. 1.5 gigs is going to be more than enough for most customers. The limitation is going to be at the source site, so at your primary office or your secondary or remote offices. That's where you get down to the concept of the thin straw. Usually people are provisioning small pipes there. That's where you really want to spend the time looking at available bandwidth.
Okay, and actually a follow-up to that is, will Zerto work with layer 3 connectivity?
Will it work? It will. So the connectivity that you have to have back to your production environment, we don't support NATing is all there it is, but we'll support VPN connectivity, so L2TP connections. We also support direct circuits, MPLS circuits. We just don't support NATing. So if you're trying to connect to OVH's backend Zerto environment from your environment, it can't be NATed. It has to look like a routable network to you to be able to connect to them.
Okay, wonderful. Well, with just a few minutes left, we're going to wrap up for today. If you have other questions, feel free to reach out to us. As I said, we will be sending out this recording. I'd like to thank everyone for joining today. A special thank you to our presenters, Mike and John. Great job. And as a final note, for latest news, product information, and promotions, please follow us both online. Thanks again, everyone, and have a great afternoon.